Wireless analysis using a spectrum analyzer. By the time we're done here, you will understand wireless spectrum analysis and use it to troubleshoot network issues. When you talk to most network engineers about troubleshooting Wi-Fi, they'll immediately think about a tool like this, which simply shows all of the different Wi-Fi networks within the area. Now, this just happens to be the area that I'm in, which is pretty darn saturated with 2.4 gigahertz networks that are spread across many different channels, even beyond the standard 1, 6, and 11 clean channels. Looks like some jerk brought up a wireless network on channel 9, which is really causing all kinds of issues. And the modern network professional will be like, well, there's your problem. You've got somebody that's sitting there on channel 9 that's causing all kinds of issues. Look how powerful that wireless network is. It's at negative 40 dBm. That must be standing virtually right next to you. That is definitely the source of all of our problems. But is it? I mean, you can see right now this little wireless tool is saying, hey, the rating's not available. Connect to a Wi-Fi network on this band, because I'm actually connected on the 5 gigahertz band to the wireless network resolution tech. And you can see right there, it's like, hey, you've got a perfectly clean channel. But if my network is experiencing poor performance, I have no idea why just by looking at this tool. I can't see utilization. I can't see interference. I can't see ... fill in all the blanks of the things that I can't see, simply because a wireless card on your computer is only geared to see wireless networks and communicate on 802.11 based wireless networks. It can't see interference. It can't see noise. You'll see a lot of wireless card manufacturers make up algorithms where they're like, well, the noise is about blah, and they'll throw out some number. But it's not real, because the wireless card, again, is only able to see 802.11 based network information. It doesn't have a chipset to understand Bluetooth. It definitely can't speak the language of a microwave oven. So when you go heat up your tuna fish sandwich, which is a huge crowd pleaser, all you see is your wireless performance going down. The normal network engineer will be like, well, that's because we've got a network there on channel 9 really messing things up. Well, that's where spectrum analyzers come into play. These things are designed to read the energy in the air over specific frequencies. Meaning, rather than joining a 2.4 gigahertz network, for example, these little adapters will look at the 2.4 frequency spectrum and say, what stuff is floating around here? Now, there are a whole bunch of these things out there. I just put some of the ones that I've had experience with right on the screen. MetaGeek is probably one of the more popular ones. They make this adapter called a Y-Spy card, and it usually comes bundled with their Channelizer software. That's what I'm going to be showing you in just a second. Now, that little gem runs about $500. Right next to it, I have Ekahau, which looks almost the exact same, and looks like, man, what a deal. Instead of $500, I could pay $5,000. Sign me up. Well, that's just because Ekahau doesn't sell this individually, at least not that I've seen. It always comes bundled with their full site survey software. So they're all about not just finding spectrum interference, they're about planning an entire Wi-Fi site. This is one that I found pretty recently, and it's pretty awesome for the price that it is, $69, a little box called RF Explorer. Now, you actually have an on-screen display with this guy, so you can use it without being connected to a laptop, or you can connect it with a USB cord to a laptop and get a much more colorful display. And I only recently stumbled on this one. It's actually used to analyze Bluetooth signals, but that just happens to be in the same frequency spectrum as your wireless networks, at least the 2.4 gigahertz space. And this is kind of a hack your own way through it, meaning if you buy that Ubertooth one, you'll get a little raw looking card like that, but you have to supply your own software. Now, unless you're really studly, you're not just going to start coding your own program. There are usually applications out there that you can find, like Wi-Fi Explorer, for example, which is built for Apple computers, that can take an Ubertooth one and use it for 2.4 gigahertz spectrum analysis. So you have to add in the cost of the software, which I think is about $79 to your $115, but that still makes it a pretty sweet deal for a spectrum analyzer. So I'm going to open up a program that I have called Channelizer Pro. It's actually MetaGeek's program, but I'm using it with my Ekahau adapter. It recognizes, there must be some kind of partnership, because it recognizes it as a Y-Spy DBX3, which is a model that MetaGeek doesn't actually create. So there's some kind of partnership going on between the two that allow the two to interoperate. And right now I'm looking at the 2.4 gigahertz band, and I can see my 11 channels going across, actually 14 channels of of spectrum use, but we know that channels is a more human-friendly way of communicating what's actually going on with the frequency. So if I really wanted to see the frequency, I can see that as well. Now, what I'm seeing on this picture is 4 different panes that give me a huge amount of information. And I want to describe those to you before we go on site and actually use this tool to troubleshoot. But actually, before we even do, this adapter, this Ekahau adapter that I'm using right now, actually can do 2.4 or 5 gigahertz, but not at the same time. So if I flip over, I'm going to lose all of my information for 2.4 because it's using a common adapter. It can only measure one frequency at a time, if you will. And that's, as you get into those handheld devices that, get into the tens, 20s, $50,000 for them, then you can get, things that measure both at the same time. But most of the time when we come to frequency analysis, if we're troubleshooting, it's going to be in that 2.4 gigahertz space because there's so many problems in that frequency spectrum. So what I see here, first off, is it looks like this top graph is the amplitude, the signal strength that's currently looking at the max trace. Now I'm going to click this little display current trace on because that will let you see the radio energy that it's recording right now as it's measuring the airwaves that it's using to generate that maximum trace value, right? But this really isn't that useful to me because I'm like, okay, well, that's great and all. I can see that on channel 1, it looks like, we're at a maximum of 71, or channel 4 is maybe a maximum of, looks like, negative 34. That's great, but I'm more interested, first off, on the average value. So I'm going to turn off the maximum and just say, show me on average from all these measurements that you're recording, and I'll display this so we don't all go ADHD on ourselves. Show me the average energy that you're getting on these channels. That's a little more useful. So I'm going, okay, well, looks like on average, over here on channel 9, channel 11, we're kind of in that 60, 70 dBm signal strength area. Okay, that's interesting. Then I can also show the energy by, first off, amplitude. It says, okay, well, I want to see how much stuff, how much noise am I hearing, how much energy am I hearing at the different signal strengths. And you can see that, down here at what's considered that noise floor, there's just a lot of, that's what I referred to earlier in the series as like whispers. And that's why we want a strong signal to noise ratio. We want a stronger signal then we actually have noise, right? So that's interesting. We can also go over here and say, show me the color by density, how much dense communication, how much, I'm trying to think of a good way. It's like how thick is the communication at each one of these signal levels. That's interesting. And I can also see the color by utilization. This is actually one of my favorite because I can say, okay, show me how utilized in terms of radio frequency are each one of these spectrums. And what I immediately see is, okay, well, it looks like channel 1, channel 2 area, which we know that channel 1 on 2.4 gigahertz is actually a little kind of spectrum grabber that grabs channel 2, channel 3, and kind of spans over there. So it looks like we're definitely getting some energy on there, right? Now I look over here at this channel 9, that bugs me. I don't know what that is, but it bugs me right now because there's something, and I think it showed up when we looked right here. We saw this channel 9 where it's just like there's this strong signal of something on the 2.4 gigahertz space. And I see it here on the spectrum analyzer that there's just like this. So my guess, if I were to take a stab, I'd say that's like a video camera or some kind of surveillance. Thank you, Outlook. Some kind of surveillance that is gobbling up that spectrum and just constantly streaming traffic. Now, right below it, it's perfect because it shows what this waterfall is. This is known as a waterfall graph, which shows this energy over time. You actually see it right here kind of live, and over here it's recording it historically. So if I want to do a recording, like leave a laptop doing spectrum analysis for a couple hours and come back and see what happened during that time so I don't have to sit here and stare at it, I can actually record it and go back over time. This is cool because, let's just say this goes away. Ooh, I just thought of something. This will be really cool. Hang on one second. So I have to forgive the raw video. I didn't plan on doing this, but I actually got this little handheld widget called Wi-Fi Metrics by a company called Nutsaboutnet. And I say that just because it's a funny company name. But right here, you can see one of the options. I know it's really tough to see, but it says air horn, which is a feature that allows you to just blast wireless signal on a certain channel. And it's saying, okay, how about 2.4 gigahertz? What's the power level? And I'll use single mode, which just blasts one channel. Channel 6 sounds great. I'll go to next. Power level, it's paused, so I'll hit enter. and it's now active. And what I see on the screen behind me, and I'm looking back at Channelizer, and now Channelizer does this over time. So it's going to take a little time for this air horn that is currently blasting signal in this whole radius to show up here. But you can see slowly but surely my utilization is starting to creep up here. But right away, look at on the waterfall what I see. On the waterfall, it's immediately gone red because, again, the waterfall is more instantaneous over time, whereas this utilization down here, which, can you see that slowly creeping up right here? Up here, it's slowly adjusting itself to, look at the density that's coming from that air horn. But right there on the waterfall chart, it's saying, man, I'm getting hammered on channel 6. So right now, if you had your users using channel 6, as the 2.4 gigahertz, they'd be like, shaking their fist in the air. I can't connect. My performance is slow, blah, blah, blah. And the network engineer who's just looking at this is like, well, it must be your laptop. It must be, you've got a Mac, Exactly. We just make stuff up because that's what we do when we don't know what's going on. But if you've got a frequency analyzer, you're like, oh man, I mean, if you had this thing recording over time, hang on, let me turn this guy off right now. I'm going to hit enter to pause it, which stops that signal blasting. And you can see that right there on the waterfall. Now it's going to take time for this guy to adjust because this is an average, and same thing with this utilization will slowly creep down. But right here you can see, bam, on the waterfall, it tells the story perfectly because it's like, yeah, right there on that channel 6, that's we saw right there. And if this was recording and I went back over time, I could be like, man, some kind of thing. Now this just shot raw signal strength from this air horn right here. But I mean, maybe there's an airport, maybe there's a microwave oven. Who knows what that kicked on at a certain time and caused all kind of interference. You would never know it unless you were running a tool like this. Well, at this point, you now have enough knowledge under your belt that I think we can take these skills on site to an actual situation and learn as we go. So we are literally going to school. This time, we're not going to learn, we're going to help others learn. We're being brought into a student testing environment, but student tests aren't like they used to be where you'd fill out the Scantron forms. I don't know if anyone else, like when I saw this picture, literally my stomach tightened. I was like, oh, I hated Scantron forms. But now all of the student testing is being done online, which results in a high-density wireless environment where you've got a whole bunch of student laptops that are sitting there, all needing wireless connectivity to have a test go well. Now, this is kind of a high-stress environment because if the test begins to freeze, I mean, you have not only the testing anxiety that the student experiences, but also the anxiety that there are technical issues. So we're being brought in there to make sure that this exam goes well. Well, welcome to our classroom. So just to get things ready, I already pulled all these student devices out of that laptop cart back there, powered them on, they're all connected to Wi-Fi. Now they've got a pretty sweet configuration. So they've got the ceiling WAPs, which provide the access to the majority of the school, but I want to show you what they did on the back of this cart. They actually took a Ubiquiti wireless access point and they set it up in such a way that every classroom that they go in, they plug this Ubiquiti WAP into a wall jack and then get the wireless access that they need for that classroom without having to set up wireless access points in every single one of the rooms. So definitely a budget conscious thing. So the reason that we're here right now is because the school is going to be doing some state standardized testing and they want to make sure that it's going to work before they bring a whole classroom full of students in and get them all online. So we are here to baseline and make sure that we have adequate Wi-Fi coverage for this room. Now, we've kind of been handed a bad hand in this whole deal because these laptops were sort of a deal of the month, and they only have 2.4 gigahertz wireless cards. So that means they're all going to be fighting for that limited 2.4 frequency space, right? So the first thing I'm going to do is establish a baseline that we have with Ethernet. What I did was I unplugged their IP phone from the wall right here because that was about the only wall jack that I found besides the one I plugged the wireless access point to. Plugged in my Cat5 Ethernet cable and ran it to one of the student devices sitting right here. And I downloaded a program, well, I mentioned it earlier in the video, called iPerf to the desktop. Now, the school wouldn't look too fondly upon me adding my screen recording software to the student devices. So what I'm going to do is I'm going to run iPerf right here from the desktop. I'm actually going to put my camera down and see the performance level that we're going to get. Now, I've already set up iPerf on the server, so I'm typing in iPerf3/C, and I know it's very hard to see because I'm balancing a camera in one of my hand. 10.223.5.250, which is the on-site server. And I'm going to do -T for time, and we'll do 20 seconds just to give us a good test of that. Hit the enter key. And we are seeing bandwidth of about 336, 317, 311 megabits per second. So I would say the LAN connectivity speed on this laptop is definitely in that 300 megabit per second range, just using iPerf to the server. Now, these are gigabit network cards, so that at least establishes a baseline. There's our average 324 megabits per second. All right, so I'm back on my laptop that does have screen recording software, and I actually joined the same wireless network as the student devices. And so a lot of the student devices have gone into power save, but that's all right. I'm just going to run a baseline. Now, you can see I put on my desktop this iPerf, so I'll just kind of drag that right there. Put change directory right into that folder, and there's iPerf. So I'll do iPerf 3 -C, which means I'm a client, and I'm going to access 10.223.5.250, which is the server here running the iPerf software, and I'm actually running that on port 5202, and we'll do -T for 20 seconds. So I'm going to run this test for 20 seconds over the Wi-Fi and see how we're going. So that's not very good at all. So I'm seeing right there we got a 2 megabit per second, 1 megabit per second. This Wi-Fi test is bad. This is dismal. Like, they're not going to be able to run their student test at all with that. So I'm going to go over here and grab my Spectrum analyzer. Jam this guy into the laptop. And let's open up our channelizer. Let's just see what's going on. First off, let's find out what channel we're even using here. So I've got this Discipulus network here on right there, channel 1, 2.4 gigahertz, 802.11n. Good. Okay, so let's close that down. And well, look at that. There's the problem. We've got. Look at this. This is like picture perfect. We've got channel 1 that is just dying. Look at that. It's just totally, fully 100% saturated. Look at that waterfall over here. You've got just, it's streaking, like there's a streak going down this entire thing. Utilization down here at negative 80 dBm, which is a pretty good baseline to go with. 100% utilized, excuse me. So we're dying in this classroom right now, and we're expecting all of these student devices to get on here. So all we're doing, if I run an iPerf test, is just throwing more madness into that giant red blob of death. Now, the beauty of this is, look at this. Now, we're looking at the 2.4 gigahertz spectrum, and I've got channel 6, channel 11. That is like nothing, zilch. So here's what I'm going to do. I'm going to go into Internet Edge and get connected to my wireless controller that shall remain nameless. All right, I've logged in, and take a look at this. I've got US 1005 LT01 purple cart. That's the one that I'm dealing with. Auto channel 1, and if I look, I clicked on that WAP, and I see channel 1 is 89% utilized. Hi, likely a problem. I actually had to tether my cell phone to my laptop to even connect to this because the Wi-Fi was so saturated, I couldn't get a good connection out. So what I'm going to do is I'm going to go into this guy based on what I'm seeing in Channelizer, and I'm going to jump this guy over to channel 6. That looks a lot better. So we'll go radios, we'll go to channel, drop over to channel 6, cue those changes, and apply. There we go, and now we'll wait while that wireless access point reboots and see what happens. You can see the WAP provisioning right there. All right, there we go. We've got channel 6 flipped over, and it looks like we've got 6 clients already reconnected, but look at this. So we've got channel 6 now climbing up in its utilization because we've got some student devices joining there, but there is still a mountain of activity. Something is gobbling up the entire channel 1. We have no idea what that is, but we know that that channel is definitely sucked dry. The other thing worth checking while we're here is just to open another wireless analyzer, just to look at the wireless networks that are out there. We'll do a quick analysis. There we go. Now we've all shown up, and I can see just from the wireless networks that are here, it looks like just a blur of them on channel 1, along with, I see a Direct 49 HP Office Jet, so there's a printer consuming that. There's some overlapping networks down there. It looks like somebody, did you see that right there? There was a network for just a moment that appeared, it looked like on channel 3, splitting these guys called Shogun. So there must be some far away wireless network that's showing up here and there.
Then right over here, we see the network that we're connected to, Disciples, and that's why we're getting such a good connection is, yes, it looks like there's some competing wireless networks on there, but by far, this is that wireless access point sitting at the back of the room on that laptop cart. We've got an amazing signal from there. Oh, there you see that CenturyLink. Whoop. That CenturyLink network popping up right there. So there is definitely a lot of competing signals on that 2.4 gigahertz, but since these student devices are all running on that same frequency, we're kind of stuck. All right, so I've got my laptop now reassociated with this Disciples network. Let's open a command prompt. Whoop, I can type that okay. And drag that folder right onto the command prompt just so it saves me the typing. And we'll go change directory into that iperf folder. We'll do iperf 3, and we'll do -c of 10.223.5.250. We're just saying we're a client of that server. Dash port 5202, and we'll do -t20. And let's just see what it looks like on channel 6. Yeah, that's better. There we go. Now we're seeing, sure, the speed is dropping down, but we're at least getting good communication there from 65 down to 10, back up to 55. So we're in that steady range of actually getting bandwidth through, which we saw on channel 1 was completely decimated by something that was happening out there. There's our average speed, 39 megabits per second. Much better.
Now, I mentioned at the beginning of this nugget that you will understand wireless spectrum analysis and use it to troubleshoot network issues. So here's what I'd like you to do. I'd like you to use your spectrum analyzer at your home to identify strong and weak areas of your network. Now, immediately that may trigger in your mind, my spectrum analyzer? Do I have one of those? And I would say yes. If you're serious about getting into Wi-Fi, you need to get one. I gave you a list of recommendations right at the beginning, but that's just a very limited set. I would encourage you to have some fun. Go on Google, search for budget wireless analyzer or budget RF spectrum analyzer. Just make sure you're getting something that truly sees the RF spectrum for 2.4 and or 5 gigahertz spectrums, not just something that shows those wireless networks like I was showing you most network engineers stumble into. Once you're comfortable doing it at your home, and I truly mean that, it takes time to get comfortable with an RF analyzer. The stuff that I showed you in this video should have given you a huge head start on that, but still you're going to see things, you're going to experience things, you're going to turn on options and off options. That really just needs to soak into your pores to where using an RF analyzer becomes second nature to you. Once you're comfortable in your house, take your spectrum analysis on the road. Go to a public location like a college campus, a coffee house, a library, wherever, to perform spectrum analysis and make recommendations. Now, I know you're kind of like, to who? And I would say, well, initially to yourself. Like, here's what I would recommend based on what I'm seeing. But I'm telling you, if you're looking for work, what an awesome way to get some. Walk up to the counter of that coffee house and say, hey, I was running some really slow wireless access, and I'm a wireless engineer, and I was, you see where this goes, right? I could fix your wireless for $59.99, whatever. This is where the IT consultant in you needs to emerge. So at this point, you have gotten a core understanding of spectrum analysis and seen it applied in a real-world high-density environment. I hope this has been informative for you, and I'd like to thank you for viewing.